Hello everyone! Be sure to watch the previous videos to gain a better understanding of what we will be talking about today. Last lesson, we talked about the wave function and the uncertainty of the location and momentum of a wave. Today, we will be talking about quantum tunneling and entanglement. These are some of the more confusing topics in quantum mechanics. We learned that there is a wave function to describe the possible location for waves. We also learned about Heisenberg's uncertainty principle. I highly suggest that you watch the previous lesson to learn more. In our everyday lives, we don't normally see objects phase through walls, but that doesn't mean it's not possible. Usually, things are repelled by barriers, but at the quantum level, there's a probability for a particle to go through a barrier. If a particle is both a particle and a wave, then the particle must also have its own wave function. So if there is a high probability distribution up to the wall, there is a small probability for the wave to be outside of the wall. A particle can be found in the middle or outside of the barrier, and this is called quantum tunneling. The barrier limits the probabilities of the wave by applying force in the opposite direction of which the particle wants to travel. So the wave function is changed after it goes through the barrier. This is all influenced by probabilities. In fact, a lot of quantum mechanics can be described using probability and math. If the barrier is big enough, the particle doesn't pass through. To quantum tunnel, a particle needs a certain amount of energy. To help think about this, let's look at a bullet and a material. The bullet is representing our particle, and the speed represents the particle's energy. If the material is thin enough, then the bullet can pass straight through the barrier, tunneling through it. But if the material is thick, then the bullet needs to have a greater speed to pass through it. After it does go through the barrier, the speed of the bullet is greatly decreased. The decrease in energy changes the wave function of the particle. Quantum tunneling, although very unlikely, is an important phenomenon in nature. Quantum tunneling is also what causes hydrogen to fuse into helium. Hydrogen is one of the most basic elements in the universe, and when two hydrogen atoms meet, they usually repel each other, but they have a chance to appear next to each other and fuse into helium. Quantum entanglement is also similar to this. It happens when two electrons interfere with each other and become entangled. The wave functions essentially interact with each other and become similar. So the measurement of one particle is the same on the other one. Even if the particles are millions of miles away, this phenomena still works. The particles become intertwined with each other, and we instantaneously know what the measurement for the other will be. This is one of the many concepts which still isn't explained by modern physics. Quantum entanglement and tunneling are extremely hard to understand, but the math can help explain both of these phenomena. Even though the entire quantum world is random, math helps us predict how particles and waves will react. In this series, I tried to explain quantum physics without going too much into the math of how it works. Watch my next video for further information about quantum physics and the conclusion to my Capstone project. This video marks the end of this series. Thank you everyone for giving me your time to learn the basics of quantum physics. I highly recommend that you learn more about quantum physics by reading my research. And again, thank you so much for showing your support for my Capstone project by watching this video. I hope you learned a lot by watching my series. Hope to see you next time. Goodbye.